Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. And very good morning. Thank you everyone for watching this or participating in this online discussion for our process control instrumentation class. So this is basically for closure for our problem 4, which is on the design of the advanced process control. So today we're going to discuss on how that this advanced process control is important. But before that, let me check my slide first. So if you want to ask questions, so just type in the chat section so that we can discuss your question after this. Okay, guys, don't forget to comment if you have a question related to this our topic, advanced process controls. And also, if you have an idea or something that you want to share, you can also ask or type in the comment. All right, so for today online discussion, advanced control. What is basically advanced control? So let's look at this feedback controller block diagram. So this is quite familiar with us. So you have a process, and the process will have an input, and this input will be a manipulated variable for feedback control. And you have the Y, the output. So this output can be a measurement or can be a measured variables or also can be a control variable. If it's a feedback control, therefore measured variable and control variable are the same. And in the process also, we also have a disturbance variable, which basically will disturb or affect the output of our measured and also control variable. Then we have a feedback controller, and this feedback controller basically will do some adjustment regarding the error between the the set point of the output and between also the real output. So the error will be adjusted and transferred into a manipulated variables, either in opening or closing the control valve. So this is basically the structure of the feedback control. Okay. But before we want to use the advanced process control, so I would like all of you to answer or we review what is basically the first law of process control. Okay, so you can go to the menti.com and use this code to give your opinion or what is the answer of the first law of the process control. Okay, I give you about 5 minutes to answer this survey. What is the first law of process control? Okay, guys, go to menti.com and put that code and give your opinion or your answer on the first law of process control. All right, so if you have a question after this, then don't forget to comment it on the chat section. All right, guys, please answer this survey. What is the first law of process controls? So you can go to the menti.com and put that code and get the idea of what is basically the answer of this first law of process control. All right, guys. Okay, put your idea on what is the first law of process control, guys. All right, the first law of process control is very important. Otherwise, then it will basically determine either we need to have advanced process control or not. So that therefore, the first law of process control is very important for us to understand it. Let me share the result of this Menti. Some of you answer determine variables, use simple controller, use simplest controller. Instead that the rate of what? Simplest controller. Okay, put your idea there in the menti.com. Okay. So the first law of process control is basically we use the simplest controller or the simplest automated controller that can do the job. Right? That is the first law of process control. Use the simplest controller that can do the job. So it's depending on what is basically the control objective of that controller. If the simplest control or if the simplest controller can do the job, so it's the performance of this controller satisfying our control objective, then we can use that simplest controller. If the simplest controller is the feedback controller, therefore that is the one that we need to use. So that is basically the first law of process control. Use the simplest controller that can do the job. Not only the simplest controller, the simplest controller that can do the job, that can satisfy your control objective. Okay, so that is the first law. So if your first if the simplest controller is on-off controllers, then you can use that if it is satisfying your control objective. Right? But usually in the industry, the simplest controller, the automated controller, is basically a feedback controller. So remember, so this is the first law of process control. Use the simplest controller that can do the job. All right, so let's go back to our slide. Okay, so we already answered this, what is the first law of process control. Then we go to the next slide. So what is the advanced process control? All right, by the way, if our simplest controller is not satisfying our control objective, therefore we need to use advanced process control. So that is basically the idea. So that's why we need to know what is the first law of process control. If our the simplest controller cannot do the job, cannot satisfying our control objective, then we need to change it, or we need to replace it with the advanced process control. So the question now is, what is advanced process control? Okay, just simply type there in the comment, in the chat, what do you understand about advanced process control? Okay, guys, give you about 3 minutes to answer this. Just type there in the chat, what is advanced process control? Just type whatever that you understand about advanced process control. So previously we have discussed on the first law of process control. What do we mean about advanced first law of process control? And now is, please answer this question about advanced process control. What do you understand about advanced process control? And just type there in the chat, what do you mean about advanced process control? So I'll give you 3 minutes before we continue to the next discussion. Guys, please answer this question, very simple question. What is advanced process control? All right, some of you answering this, advanced process control is a technology that maximizes operational performance and process profitability. Thank you. Include cascade control, ratio control, feed forward, and split range control. All right, thank you. Atika, technology that maximizes operational performance and process profitability. another friend of yours, improving regulatory loop control. All right. Wow. Fatiha IPC broad range of techniques and technologies implemented within industrial process control system. IME talking about techniques and technology implemented within industrial process control system. Okay. Xinyi, Lo Xinyi, advanced process control refers to a broad range of techniques and technologies implemented within industrial process control system. Oh, almost the same. AFIC, optimization of the technology's performance. Winchin, advanced process control refers, macam sama je jawapan korang ni. We want evaluate the set of set variables. Okay, so thank you for your, oh, ada lagi. Putri, deploy optionally and in addition to basic process control. Wow. There's another one here from Eng Ying Lee. Specialized strategies and provide enhanced process control beyond what we can obtain with conventional single-loop PID controllers. Characterized by unmeasured variable and disturbance, long time delay, process constraint, changing operation condition, and also process nonlinearities. All right. Thank you for your comment. So now we look at this. So we have advanced. So if in order to ask or to answer this advanced process control, what is the advanced process control? We need to refer back to our first law of process control. Right? Our first law of process control is saying that we use the simplest controller that can do the job. Okay, use the simplest controller that can do the job. So in industry, the simplest controller is basically the feedback controller. So if the feedback controller cannot do the job, cannot satisfying our control objective, therefore we need to use other than feedback controller. So other than feedback controller is, we can categorize as an advanced process control, or sometimes we call it feedback control enhancement. Okay, feedback control enhancement, which is other than feedback controller, that we call it advanced process control. That's why we call it enhancement of feedback controllers. So if you look at the type of, if you analyze the type of advanced process controller, advanced process controllers such as ratio, cascade, what else? Feed forward is basically based on feedback controller. So we do some enhancement, we do some improvement such that this feedback controller, if we enhance it, and we call it advanced process control, and it can satisfy our control objective. That's the reason why we need to use, or not the reason, what we call it advanced process control. Okay, it's an enhancement of the feedback process control or feedback controller. Since the feedback controller cannot do the job, cannot satisfy our control objective, therefore we need to have an enhancement version of feedback controller. All right. Then we go to the next slide. Where's my slide? All right. So the next question, why that we need to use advanced control? We already know, we already discussed that advanced process control is some so-called enhancement of the feedback controller. But the question is, why we need to use advanced process control? Okay, you can answer that in the Menti. Okay, why we need to use advanced process control? Go to menti.com and put that code and give your opinion about why advanced process control. We have discussed that advanced process control is the type of enhancement of the feedback control. And we also have discussed about the first law of process control, and now why advanced process control. Okay, guys, put your answer there. Why advanced process control? Give your opinion about why advanced process control. Why that we need to use advanced process control. I'll give you about 3 minutes on this. I answer this survey about advanced process control. Okay, guys, thank you for not thank you, because this is basically our class, so we need to have a participation and discuss. If you have a question related to these discussions, you can just simply type there in the comment. But meanwhile, you need to answer this question: why that we need to use advanced process control using menti.com. Okay, wow. Let me share the result now about this advanced Menti result. Where's the Menti? Okay. Whoa. Reduce costs, provide enhancement for to increase efficiency, yes, fulfill control objective, efficient and time saving. Okay, what else? Basically, that reason why we need to use the advanced process control. So most of you reduce costs, maximize operating performance, improve efficiency, increase efficiency. Okay. So still have 1 minute. 1 minute to give your opinion about the reason why we need to use advanced process control. Thank you, guys. So all of this is basically the control objective, either to reduce costs or improve profitability, plans more complex, easier to use tools is basically the objective, some of the control objective. All right. Okay, thank you for give your opinion about this advanced process control. So we need to continue. So it's basically why that we need to use advanced process control. You need to refer back with our previous discussion about the first law of process control and also the what is the feedback process control, definition of the advanced process control. Right? If we if we look back, our first discussion about the first law of process control, so which is the simplest controller that can do the job. Okay, so if this simplest controller can satisfying our control objective, therefore we need to continue using it. So in this case, for our class, the simplest automated controller is feedback control. So if the feedback control cannot satisfying, or the performance is not satisfying our control objective, therefore we need to use other than feedback controller. So which is the advanced process control. And we define it as an enhancement version of feedback controller. So because of this simplest feedback controller cannot do the job, and that's why we need to use advanced process control? It's basically to satisfying our control objective. So what is a control objective? It's basically the one that you put in the Menti. Okay, so we have about 21 response. So all of those are basically representing the control objective. So that is the reason, because our first law of process control saying that the simplest controller that can do the job, that is basically our law that you need to we need to use if you want to design a controller. Just use the first law of process control. If the simplest controller can do the job, satisfying your control objective, then you need to continue. So no need for you to enhance it. But if that simplest feedback controller cannot do the job, then you need to enhance it, okay, using advanced process control, because it cannot satisfy your control objective as what you mentioned here. All right. So thank you, guys. Then we continue with our slide. So we look first at this one type of enhancement of the feedback controller, which we call it feed forward. Okay, which we call it feed forward controller. So this is the two block diagram of the feedback controller and also the feed forward controller. Okay, I would like to ask you, okay, just put in the comment, okay, just put in the comment what basically the measured variables of feedback controller. Just type measured variable MSV, okay, MSV, FB, apa dia, MSV, FF, apa dia. So what is the measured variable for feedback controller and also the feed forward controller? Okay, we do the, okay, we revisit our first what we call it learning objective for this process control, which is a variable classification. So what is the control measured variable of feedback controller, and what is basically the measured variable of feed forward controller, by referring that diagram, two block diagram. Okay, just use that symbol over there, the Y, D, U, YSP, whatever. Okay, comment, put that in your comment. Measured variables of feedback control and also measured variable of feed forward controller. Okay, guys, what you need to do is just type in the comment the measured variable for feedback and also the measured variable for feed forward. Okay, feed forward disturbance, feedback control variable or Y. Feed forward D, okay. All right, so this is very important for you to understand the measure variable of these two different controllers, because that will determine the advantage and also the disadvantage of these two different controller. All right, so I think all of you already understand this. So the difference is between the measure variable of the feedback controller and also measure variable feedback controller. You measure your control variables. Okay, whereas feedback controller you measure disturbance. Okay, measuring disturbance, while feedback controller basically measuring control variable. All right. So since these two having different measured variables, therefore their objective is also different. Okay, their objective are also different, since you know that control variable, a feedback control variable, feedback controller measuring output, which is measuring the control variable, whereas feed-forward controller measuring disturbance. So, based on these questions, can you identify what is the objective of feedback controller and what is the objective of feed-forward controller? Since you know that the measurement is different, so what is the objective of feedback? You just put the feedback FB, objective apa dia, just type there, FF apa dia. Just put there in your comment. Feedback controller measures control variable. Feed-forward controller measuring disturbance. Of course, since you are measuring different variables, therefore the objective will be different. The control objective will be different. So can you put in the comment what is the objective of the feedback controller and what is also the objective of a feed-forward controller? Okay, just type there in your comment the objective of this. Okay, correct. Chayu corrects the unmeasurable disturbance. FF eliminate the effect of measurable disturbances. Okay, a very good definition of the control objective between feedback and also the feed forward. What else? Who want to respond on this question? The objective of the feedback controller and also the objective of the feed forward control. I'll give you an example here from our friend here. Remember that we are talking about control objective. Why that we need to compare between the feed forward and feedback? Because they are the same structure. Feedback and feed forward controller are the same structure because they are single input and single output. It's different. They are different from a ratio controller that we will look after this and also the cascade controller. So that's why we need to compare between the feedback and feed forward first, because they are the same structure. They are having the same structure, single input and also single output. The only difference is the input, the measurement variable will be different. As what we have discussed previously, that feedback controller measure the output, which is our control variables, whereas feed forward controller measures disturbance. So since they have a different measurements, Therefore, their objective will be different. So that's come with our next question is what is basically the objective of feedback controller and what is also the objective of the feed-forward controller. Okay, just put that in your comment, your opinion on these control objectives. So there is an example of your friend here, the objective. You can refer back to this controller structure of the feedback and also the feed-forward. I cannot say that the opinion by your friend here, Chayu, is correct. You may have your own opinion about this control objective. Okay, guys. If you look at the structure, okay, if you look at these two control structures, we have a feedback and we have a feed forward. Okay. Basically, feedback and feed forward controller, their objective is the same. Their control objective is the same, to maintain our control variables at desired set point. That is the control objective. Okay, remember, since their structure are the same, single input and single output, therefore their objective also the same. Feed forward and feedback controllers, the objectives is basically to maintain the Y, the control variable, at the desired set point YSP. The only difference is the action. Okay, the only difference is the action. Whereas at the feedback controller, you measure the error. Okay, you are measuring the error between the current output or the current control variable value with the set point, because the feedback is already happened. Okay, it's already happened. Therefore, you need to do the action based on the error between, or offset, we call it offset, between the current control variable value with the set point value. Okay, but still objective is the same, to maintain the Y. The action is depend on the error, the offset. That is the feedback, because it's already happened. Whereas in the feed forward, the objective is still the same, to maintain Y at the desired YSP by adjusting the action of the opening of your control valve depending on the value measured, okay, measurement based on the measurement value. So it's depend on your disturbance value, because it's a feed forward. It's basically what we call it, prediction. Okay, prevention. Action is basically prevention happen if the disturbance is bigger, coming into your process is bigger. Therefore, you need to do some action to your control variable. To your manipulated variable, either you want to increase or decrease depending on the action of that. So prevention versus correction. But the objective is still the same, which is to maintain Y. Okay, you still measure the Y, you still monitor the Y, but you are measuring the disturbance for the feed forward, and you're measuring the same Y for your feedback. So that is basically the difference between the action in the feed forward and the feedback. But the objective is still the same, to maintain the Y. The only difference is the action. Okay, action to do the correction, and also the action to do for prevention. Okay, so that is the difference between the feedback and also the feed-forward controller. So let's continue to this slide. So this is what they call it, the example of the feed-forward controller, feedback controller for a boiler drum. This is for the level controller. So you're measuring the level of the boiler drum and manipulated the feed water. This is for feed forward if and only if the steam flow rate become a disturbance. Okay, if the steam flow rate is not a significant disturbance, so you can use this structure, which is feedback, whereas feedback can do the job. So remain it as it is. But if the stream flow rate is a significant disturbance that will affect the level of the boiler drum, therefore you need to measure it. So you need to use a structure of the feed forward. You cannot use the disturbance, the feedback structure anymore because the disturbance is significant. Right? That's the reason we need to use feed forward, because of the significant impact or effect of the disturbance to your control variables. Just look at your control variable. If the impact is significant, therefore you need to use a feed forward controller. Okay, this is another structure. So can you tell us, guys, what do you understand? What is this structure? Put that in your comment. What kind of control structure of this? It is not feedback. It is also not a feed forward. Feedback is you're just maintaining your level here. For example, in this case is for the boiler drum level. If the level you can maintain it, no disturbance impact, then you can use a feedback. But if the disturbance have a significant impact to your level, therefore you need to use feed forward controller. You just measure, you measure what we call it, the disturbance flow rate there. If the disturbance having a significant impact. If the disturbance have a significant impact to your control variable, and you also need to maintain a control variable at the desired set point, so you need to use this structure. So what do you call this structure? Just put your answer in your comment. I'll give you about 1-2 minutes to put the answer there in your comment. So guys, what is basically the structure, the control structure of this controller? Is Izati saying that it's a feed-forward feedback controller. Wenchin also saying a feed-forward feedback controller. Whereas Wei Wang saying a feedback feed-forward. Okay, which one is first? Feedback feed-forward, feed-forward feedback. Okay, there is another question there. Either is a feedback feed-forward or feed-forward feedback. This is a FFFB structure mentioned by Wenchin. Wei Ying saying it's a FBFF. So which one is the correct answer? FBFF or FFFB? So in answering this, you need to look at the structure, which ones become primary or which one is become secondary. Okay, think about it. I give you time to discuss this, and yeah, you may discuss with your friend about either it's a FBFF or FFFB by looking at the structure. All right, so we continue with the next slide. The feedback versus feed forward. So if you look this, as I mentioned before, the control objective of feedback and feed forward are the same. Maintain Y at its set point despite of disturbances. So this is the difference. For the feedback, you measure the Y, compare it with the set point, and you adjust the manipulated variables to minimize the offset or to minimize the error. So whereas in feed forward, you measure the disturbance, you adjust the manipulated variable such that the Y is the same with the set point. So that's why I'm saying that since they are the same structure, seesaw structure, single input and single output structure, therefore the objective are the same. Maintain the control variable at a set point. The only difference is how you do the action. Okay, so this is the structure of this two feedback and also feed forward controller. Okay, next we go to this advantages. Okay. All right, about either it is FFFP or FBFFs, then you can discuss after with your friend after this in your team. So go to this Menti. Guys, go to this Menti. And what is basically the advantages of feedback controller? Say you just use the code 204935 there. The advantage of feedback controller from your understanding. We still okay. So we have about 30 minutes more to finish our online class here. Go to the menti.com and use that code to answer the survey about advantages of the feedback controller. From your understanding, what is the advantages of the feedback controller? Go to menti.com and use code 204935 to answer these advantages of the feedback controller. Okay, go menti.com All right, some of you already responded. Thank you. Let's look at your response on this survey. Simple, correction action, all right, correction action, fast corrective action, can reject many disturbances. Wow, can reject many disturbances. Ensure reliable loop, add stability, reduce error. All right, so thank you for your response. It's basically the most the big advantage of using feedback controller is you're able to maintain the set point. That is the big advantage of the set point. Why? Because you measure your control variable directly. So sure, you're able to maintain the set point. Okay, so if your set point changing by using feedback, it is an advantage using feedback if you have a set point tracking problem ataupun kita panggil dia servo problem. Okay, servo problem. That is the advantage of the feedback because of the servo problem. If your quality of your set point is changing, therefore you need to use feedback controller because it's able to keep track the changing of your set point. That is the advantage of the feedback controller. Okay. However, this feedback controller also have a disadvantage. Okay, it also has a disadvantages. So remember that the feedback is okay. The advantage of the feedback we put here in the comment. Right. So that is basically the advantage of the feedback controller. Excellent in keep tracking the changes in set point. Okay. All right. So we're gonna have another survey on this, which is disadvantage. Let me share. Okay, dah hilang dah saya punya. Okay. Guys, go to this Menti also. What is basically the major disadvantage of feedback controller? We need to understand this advantage and also disadvantage of the feedback controller before you want to design an enhancement controller for that. Okay, for this feedback. Kalau kita tahu kelebihan dia dan kalau kita tahu kekurangan dia, sebab itu kita ada reason, kita ada alasan untuk kita upgrade feedback controller ni kepada advanced controller. Dan dia bergantung kepada proses. It depend on the which process that you want to control. So the enhancement is basically is not the same as the reason is because the process is not the same. It's also depending on your control objective. So go to the Menti and use that code 113219 and answer what is basically your understanding about the disadvantage. Okay, you can stop answering for that advantage and then just go to the disadvantage survey. Disadvantage, all right, disadvantage. Okay, let me share this menti.com's page. Not include disturbances. Overall gain reduce. Oh, overall gain reduce. Wow. Thank you. Very good response there. The major disadvantage. What is basically the major disadvantage? Major advantage of feedback is excellent in keep tracking the changes of the set point, meaning the servo problem is very excellent. You can use the feedback if you want to, if your objective is to keep tracking your set point. But there is a major disadvantage, as what mentioned here. Complicated. Wow, complicated. Feedback is not complicated. Measured about disturbance, effect of disturbance upset process. There is a disturbance. Okay, disadvantage of feedback adalah for regulator problem. Okay, we know that there is a, we have analyzed. That's why that's the reason. If you do the feedback control analysis, we derive two transfer function, which is the servo transfer function and regulatory or regulator transfer function. Okay, because this representing advantage and also disadvantage of feedback controller. Advantage of feedback controller, okay, excellent in keep tracking the servo, the set point changing, whereas if the disturbance, the impact of disturbance is significant, so feedback controller cannot reject it. Okay. So I commented there in the chat about the disadvantage of feedback. Cannot reject the effect of disturbance, especially if the disturbance, the impact is significant. Okay. So that's why if your process have a significant effect of disturbance, you cannot use feedback controller. Okay, you cannot use the feedback controller. So how to identify it? So you need to have several what we call it tasks to do. It's basically one of them is based on the variable classification table that we have analyzed previously in our first learning issue, or not learning issue, learning objective. Variable classification, make sure that we know that there is a disturbance for this control loop. So and from that you need to do another analysis, which is to analyze the impact of the disturbance to the to the control variables. So that's why you need to have a transfer function related to that input and disturbance versus output or control variables. So which basically you already have that in your regulator problem transfer function. Okay. So once you have that, then you identify or you do the analysis. If the feedback controller cannot reject the impact of disturbance or the effect of disturbance, therefore you need to use other than feedback controller. For example, you can use cascade controller, you can use a ratio controller, or you can use a feed-forward controller. But the simplest is you need to try with the feed-forward first. Okay? So there is a several option for you to enhance the feedback controller, especially if there is in the presence of disturbance. So you may start with the feed-forward first, and after that analyze either by using feed-forward you can maintain your set point or not. Again, your objective for the feed-forward is to maintain the set point, to maintain the control variable at the desired set point. The only difference is you measure the disturbance impact. All right. So if you cannot maintain, you're able to reject the disturbance, but you cannot maintain the set point or the control variable at the desired set point, then you can use other than feed-forward. For example, you can use cascade controller. Okay? Or you can use the feed-forward feedback controller. Basically, feed-forward feedback controller structure is basically the same as a as a cascade. The same as a cascade. Okay? The same as a cascade controller. It's only different is which one is the inner loop located in the inner loop and which one is located in the outer loop. But it's basically as cascade controller. Or you may use the ratio control. So this is the reason. That's why in this class, we do a lot of analysis on the feedback. Okay, I think all the chapters or learning outcome that we learn in this control class all are about feedback controller, except one outcome, which is advanced process control, which is about enhancement of the feedback controller. Because of this advantage and also disadvantages of the feedback controller. There is a big advantages of the feedback controller because of the impact of the disturbance. And we know that in the real process, the disturbance is there. Disturbances are there. Okay, so we cannot basically neglect the impact of the disturbance to the feedback controller. Therefore, the enhancement or the use of feedback controller should analyze first the performance of the feedback controller. Okay, if the disturbance is very significant to the control variable yeah, it's a very significant impact to control variables, then you need to select which, or you need to reject first the disturbance. Okay, reject the impact of the disturbance. Okay, let's look at the cascade control first, because this is very significant. Adapun this is a very important point that I want to discuss here about enhancement of the feedback controller using cascade controller. Okay, let me share that first, the slide first. Again, when we are talking about advanced controller, it's basically we improve or we enhance the feedback controller. That's all. Okay, let's take a look at this. Let us discuss, because we only have about less than 10 minutes to discuss on this. Okay, guys, let us discuss on this. This is very important discussion, why that we need to use cascade controller. There is one question that I want to ask you, why cascade controller? But okay, never mind about that. We just discussed on this controller structure. Okay, this is one example of the controller structure for exothermic. Okay, for exothermic reactor. As we know, exo release heat. Okay, release heat if the exo release heat, and also for this reactor there is a several disturbance that can affect the control variable, which is the temperature of the reactor. Okay, the temperature of the reactor. And as we know that the temperature of the reactor is controlled by manipulating the cooling water flow rate. Okay, the cooling water flow rate, and the disturbance that can affect this temperature of the reactor, basically the most significant is the cooling water temperature. Okay, the cooling water temperature. And okay, let's analyze this. Since we know that the cooling water temperature varies depending on the environment, depending also on the supply. Okay, depending on the supply and also depending on the environment. Okay, kalau dia hujan mungkin akan berubah, kalau tengah hari mungkin akan berubah juga. Okay, so this will disturb the control variable, which is the temperature of the reactor. All right. So since if the impact of the disturbance is very significant, and we cannot use feedback controller because of this reason, so one thing that we can use is a cascade controller. So the first thing that you need to do if you want to use cascade controller, make sure that the impact of the disturbance is very significant. So before you want to use the cascade controller, you need to stabilize that disturbance impact or reject it first. Once you reject and you stabilize it, okay, that should be the first thing that you need to do. Okay, stabilize it. So how to do that? How do you stabilize the disturbance? Therefore, you need to control it. So in this case, you control the jacket temperature ataupun the cooling water temperature. Okay, or the jacket water temperature, the jacket temperature. So control it first. Make sure that the temperature is constant. Okay, since it is a disturbance, so if it is a disturbance, if the temperature of the jacket is fluctuate, therefore the temperature of the reactor also fluctuates. So minimize it, stabilize it first. So that should be the inner one. Okay, that should be the inner one. And once it's stabilized, therefore, after that, you can easily for you to maintain the outer one, which is the temperature jacket, the reactor temperature. Okay. So the reason if you want to use cascade is you want to maintain your primary your primary control variable, which is the reactor temperature, by stabilizing the secondary control variable, which is the jacket temperature. Once the jacket temperature stabilized, constant, no fluctuation, therefore easy for you to maintain and control your reactor temperature. So that's how the cascade comes in. Okay, you reject the disturbance first. Feedback controller, you cannot reject it. Therefore, you need to enhance the feedback controller. If you look the temperature controller, the reactor temperature controller is basically a feedback controller. Okay, it's basically a feedback controller. But since there is a significant impact of the disturbance, therefore you need to stabilize it first. Okay, so that is how that you use the feedback controller. Okay, let's analyze this. The feedback and also the cascade controller. This is for furnace. The objective of this process is basically to maintain the furnace temperature. Oh no, it's basically for you to maintain the hot oil temperature in the furnace by manipulating the fuel gas. The left hand side is basically the feedback controller, whereas the right hand side is the cascade controller. As we know, the flue gas will have a different pressure. Okay, the same thing also if you use the steam will have a different pressure. Okay, higher pressure steam, medium pressure steam, low pressure steam. So if you're manipulating steam, if you're manipulating flue gas, the pressure become a disturbance that basically has a significant impact to our control variable. In this case, is the hot oil temperature. Therefore, if the fuel gas have a different pressure, therefore the heat supply will different. Therefore, you need to stabilize the pressure of the fuel gas first. That's why in the cascade configuration, you use another controller over there, which is the pressure control, because the pressure of this fuel gas is fluctuated. Okay, it fluctuates. Therefore, you need to stabilize it. So you use the pressure control. Once the pressure is maintained, therefore the heat supply will maintain, and also easy for you to manipulate, to maintain and control the hot oil temperature. All right. So the cascade control, you want to use cascade control if there is a significant impact of the disturbance to your process. And how to do that? You stabilize the disturbance first by having another feedback control there. So cascade control is basically two different feedback controller. You stack it together. Stabilize the disturbance, and then after that, once the disturbance is stabilized, then you can control the primary control variable, which is, in this case, is the hot oil temperature. Okay, guys? So this is how basically you design your advanced control ataupun enhanced feedback controller. You need to look, or you need to analyze the feedback controller first. Okay? That's why if in your project, okay, let's reflect on your project 4. If you want to use advanced process control in your project 4, is basically you need to use feedback controller first. You need to analyze the feedback controller first. Or the first thing that you need to design is feedback controller. Don't just come up with the advanced process control or enhancement of the feedback controller. Try feedback first, because that is the simplest controller that can do the job. First law of process control. If the first law of process control fail, or the simplest controller cannot do the job, in this case, it's feedback. If the feedback cannot do the job, cannot satisfy your control objective, then you do the enhancement. Baru you boleh design advanced controller. Okay, and it's depending on the significance of your feedback of your disturbance. You can use feed-forward controller if your objective is just to if your objective is just to maintain your control variable by rejecting disturbance. If you're able to maintain the control variable, if you maintain the control variable at the desired set point, then you can use feed-forward. If you use feed-forward, you can reject disturbance, but you cannot maintain your control variable at the desired set point value. Therefore, you need to use other than feed-forward, because you cannot satisfy the control objective to maintain the control variable. Therefore, you can use cascade, or you can use ratio. So we have discussed about the cascade. So since we want to maintain the desired control variable at the desired set point value, so but there is a significant impact of the disturbance. Therefore, if you want to use cascade, you need to reject and stabilize the impact of the disturbance first. Therefore, you need to have another controller to maintain and stabilize the disturbance. And after that, baru you boleh maintain and control your primary controller, or your primary control variables. So this is one example that you're able to reject disturbance, and also you're able to maintain your control variable at the desired point. So cascade, you can use cascade dengan syarat the impact of the disturbance is significant. Okay, you can use feedforward if by rejecting disturbance and your set point are the same, or you're able to maintain your control variable. Yes, it's okay if you're able to use it, maintain it. If you cannot maintain, you're able to reject disturbance, but you cannot maintain your control variable at the desired point. Therefore, you need to use cascade. Okay, so it's basically if you want to use enhancement, or if you want to enhance this feedback controller, you need to use usually you need to use step by step. Use the same structure first, as the same as a feedback. For example, feedback is seesaw. Therefore, you need to use feed forward first. Once you try this, the seesaw controller, if your control objective cannot be satisfied, therefore you use the MIMO. Okay, the example of MIMO is a cascade or MISO. Okay, you use cascade. So that is how basically you design the advanced process control. Again, what is advanced process control is basically the enhancement of the feedback controller. Okay, so I will close this online discussion. Okay, I will close this online discussion by asking you to answer this question. Although we have discussed this, okay, although we have discussed this, so I want to see your response or understanding about this cascade controller. Why we need to use cascade control? Okay, I give you about 3 minutes to respond on this. Go to Menti and use that 955822 code to respond on this, why you need to use advanced, why you need to use cascade control. That should be our closure here. And after that, I will close our online discussion. Okay, guys, use this Menti and answer this question, why you need to use cascade control. I will share your results. Some of you already answered it. Then after that, we will discuss. I will do some discussion on this. More practical approach, fast inner loop, significant disturbance. There is a 2 reasons that I have mentioned about this cascade controller. Hopefully that you can reflect on that. I've mentioned about 2 criteria that you need to consider when you want to use cascade controller. Maintain stabilized TV. So this question is basically asking about a cascade control objective. Remember that when you want to analyze the variable in every single control loop, you need to also state the control objective. What is basically your control objective? For the cascade, the control objective is basically there is a two criteria or two objective that you need to satisfy. Okay, hopefully that I can see that point here in this main T. More practical approach, yeah, it's more practical, but why? The question asking about why. To maintain desired set point, if you want to maintain desired set point, you can use feedback. Why you need to use feed forward? Yeah, again, first law of process control, use the simplest one that can do the job. If you want to maintain desired set point, just use feedback because that is the best controller to maintain the set point. Okay. So again, this is the law and the rules that you need to follow if you want to design advanced process control. Always check your design by first law, the first law of process control. And then after that, look at the control objective. Most of you saying about maintaining desired set point. Okay, thank you for your response. So it's basically why you need to use cascade control is basically the one that I commented there in the chat. That is basically the reason why you need to use cascade controller. You need to have two reasons. The first reason is you want to maintain your set point. If your objective is just to maintain the set point, then feedback is the best option. But if there is an impact of the disturbance, then you can use feed forward. Feed forward is the best controller structure to reject disturbance. If your objective is just to reject disturbance, therefore you can use feed forward controller because feed forward controller measuring disturbance impact. So therefore it is the best controller to reject disturbance. The best controller to maintain set point is feedback. The best controller to reject disturbance is feed forward. But if your objective to maintain set point and to reject disturbance or not rejecting it, maintain and reject disturbance, sorry. Therefore, you need to use cascade. Okay, so this is the reason why you need to use cascade. You want to maintain your set point at the desired. You need to maintain your control variable at the desired set point and also rejecting disturbance. So that is the reason of using cascade. Okay, that is our closure for your problem problem 4. Again, I would like you to reflect this problem 4. I will think where that you need to do the reflection. I think it's better for you to do it in the Facebook. I will try to. Yeah, I think better for you to reflect this problem 4 in the Facebook, my Facebook page. I will give you the link of this Facebook page. Please reflect your learning reflection on this problem 4. So As a conclusion, for this advanced process control, whenever you want to design advanced process control, please refer to your first law of process control first. Okay, use the simplest controller that can do the job. If the simplest controller can do the job, satisfying your control objective, then no need for you to use advanced process control. Okay, that's the first thing that you need to check. Second, if the simplest controller cannot do the job, which is the feedback, therefore you can enhance it. So enhancement of feedback controller is, we call it advanced controller. Check your control objective. If your control objective just to maintain the set point, the servo problem, therefore feedback is the best one. If your objective is to reject disturbance, then feed forward is the best one. If your feed forward controller able to reject disturbance but cannot maintain your set point, therefore you need to use cascade, because cascade, the objective of the cascade is to maintain the set point and also rejecting disturbance. Okay, ratio and also the split range is very simple. Ratio and split range is just because it's just a simple, yeah, you can easily read it, understand it, but the cascade is very important because they have two different control objectives, which basically combining the advantage of feedback and also the feed forward controllers. Okay, guys, that is basically our online discussion for this advanced process control. So hopefully that you can have better understanding in designing your advanced process control in the future. Although you have submitted your report of the project 4, I would like to see your and also read your reflection on this learning of the problem 4. All right. So thank you for your participation in this online discussion. Hopefully that it will help you in learning about advanced process control. Okay, guys, thank you very much. And I think we need to have another one online discussion for the closure of your for our class. I think on next week, Monday. Okay, see you on Monday next week for this online closure of our class. Okay, thank you very much. Bye bye. Thank you, guys.